Okay, sir, start.
Right. Good afternoon, students. The previous days we have completed the reactions of aldehydes and ketones, some of the chemical properties of aldehydes and ketones generally. Now we are going to discuss about the cross-Reardal condensation. In this cross-Reardal condensation, it is going to be carried out between two different aldehydes. In the previous class, I have completed what when the two aldehydes of similar aldehydes, not different aldehydes or ketones will be. This type of reaction can be called as normal aldol condensation reaction. But in this crossed aldol condensation, two aldehydes are going to react together, and those are the aldehydes will be having different number of alkyl groups. That it will be first one here we are taking acetaldehyde, and the second one it will be propanol, ethanol and propanol true will be there. If both are having the alpha hydrogens here, and already we have discussed in aldol condensation, whatever the reactants are going to be involved, definitely they should contain the alpha hydrogen. That already I told, and this is explained like this. Once you see clearly, here acetaldehyde and propanol both we have taken, and both are reacting together in presence of a base. At that time we are going to get 2-enol or 2-butanol we can call, and 2-methyl pent-2-ene also. These two products are going to be two molecules of ethanol. From two molecules of ethanol will be otherwise what this 2-methyl pentanol is going to be formed. Simple self-aldol products. I means what if the self-aldol condensation is going on, the above compounds are going to be formed. If Ross-Dalton is happens, that means both the different aldehydes are going to react together. At that time, 2-methyl butanol and pent-2-enol is going to be formed, as in the second compounds reactions are going to be formed as the cross-Dalton products, which is underlined here. And similarly, ketones, which are having two different alkyl groups, are both are reacting together. Here, 1,3-diphenyl propene in one one is reacting together. So clearly, we are observing here whatever the aldehyde group present here, one of the aldehyde and another one of the ketone, when it is both are reacting together, the aldehyde group, whatever the oxygen which it will be present in this whatever the oxygen benzaldehyde లో ఉన్నటువంటి oxygen ఏదైతే ఉందో oxygen place లో it is going to be formed as double bond with the CH carbon. Similarly here, okay. So in this manner we are going to get benzyl estophenol nature product is forming here. So this is about what aldol condensation reaction. So we have seen what self aldol reactions and crossed aldol reactions, and definitely those are the reactants what we are going to take in this reaction. Definitely they should have the alpha hydrogen. Aldol reaction is a mixture of what ethanol and propanol we are getting here. After that, other reactions, if you have seen Cannizzaro reaction. Cannizzaro reactions are the reactions which are going to involve the aldehydes which do not have an alpha hydrogen atom undergo self-oxidation and reduction. Already we aware of that what is self-oxidation reduction reactions can be called. Those are called disproportionation reactions. On heating with concentrated in alkali, aldehyde and a ketone, when these are heated with a concentrated alkali, at that time we are going to get one alcohol clearly itself, one of the alcohol which it is going to be formed, and another one is what is another is oxidized as carboxylic acid salt, like what one formaldehyde and one of the two formaldehydes if we have taken here HCHO. Both the formaldehydes are treated in presence of a concentrated alkali. At that time we are going to get one of the alcohol and one of the carboxylic potassium salt of carboxylic acid. That is potassium formate we are getting. Benzaldehyde is here in the second reaction, second example if we have taken. Benzaldehyde is going to give 2 moles of benzaldehyde. That means what? Both the aldehydes are going to react together. Both the aldehydes are reacting together at that time. Both the aldehydes are reacting together at that time. What is going to be formed? Concentrated NaOH when treated together. In presence of concentrated NaOH, one of the benzaldehyde molecule is treated with another benzaldehyde. At that time, we are going to get benzyl alcohols. By means in the sense what? When aldehydes which does not have an alpha carbon. By means what? In the benzaldehyde also we can observe here clearly alpha carbon is not there. Why? The functional group attached carbon should contain hydrogen, and alpha carbon should not contain the alpha hydrogen, whatever the carbon is present attached with the CHO group. Because of that reason, the alpha carbon which is does not having the hydrogens that can be treated in presence of concentrated NaOH, we are getting an alcohol with the same aldehyde what we have taken as a reactant, as well as one of the sodium, whatever the alkali we are taking, either sodium hydroxide or potassium hydroxide, whatever the strong base we are taking here, that potassium salt of carboxylic acid or potassium salt, sodium salt of carboxylic acid here we are getting. In this manner, the Kennedyar reaction is going to occur clearly. Next one is what? Electrophilic substitution reaction. How the electrophilic substitution reaction is going to occur? Benzaldehyde, aromatic aldehyde here we have taken. When aromatic aldehyde is taken at that time, aromatic aldehydes or ketones undergo electrophilic substitution at the ring in which the carbonyl group acts as a deactivating and meta-directing group. So aldehyde is a meta-directing group, and when nitration is going to done on the benzene aromatic aldehyde, upon the any of the carbon, the nitro group is going to be substituted at which position? Meta position, because CHO group is a meta-directing group. So carbonyl group here it is acting as what? Meta-directing group clearly itself. We can know that. So these are the chemical properties of the aldehydes and ketones. And classifications as well as hybridization classifications, nomenclature, general names, physical properties, preparations, and as well as we have discussed the chemical properties till now. But now the uses of the aldehydes and ketones finally we will see once. The formaldehyde is also known as generally formalin, which is used to preserve the స్పెసిమన్స్ టు జనరల్గా బైపీసీ స్టూడెంట్స్ కనుక అబ్జర్వ్ చేస్తే మనకు ప్రాక్టికల్ ల్యాబొరేటరీ మనం ల్యాబ్లో ప్రాక్టికల్ చేసేటప్పుడు బయాలజీ పిల్లలకి బైపీసీ స్టూడెంట్స్ మీరు అబ్జర్వ్ చేయండి. మీ స్పెసిమన్స్ ఏమైతే ఉన్నాయి కదా స్నేక్ కానీ లేకుంటే ఏదైనా ఫ్రాగ్ కానీ దట్ స్పెసిమన్స్ అనేటటువంటి ఆ మోడల్స్ అన్నీ కూడా దాంట్లో స్పెసిమన్ మోడల్స్ అన్నీ కూడా ఒక సొల్యూషన్లో స్టోర్ చేసేసి పెడతారు. ఆ సొల్యూషన్ ఏంటంటే ఫార్మాల్డిహైడ్, అది కూడా 40% ఆఫ్ ఫార్మాల్డిహైడ్ సొల్యూషన్. దట్ స్పెసిమన్స్ కెన్ బి స్టోర్ in the formalin solution, and these specimens to prepare a bakelite, urea, formaldehyde, glues, and other polymeric products also. Aldehyde is also used as a primarily starting material in the manufacturing of acetic acid. Acetic acid preparation లో కూడా అదేవిధంగా ethyl acetate, vinyl acetate, polymers and drugs. Benzaldehyde is used in perfumery dye industries. Perfumery dye industries లో కూడా మనం aldehydes ని యూజ్ చేస్తూ ఉన్నాము అని చెప్తున్నాం. ఓకే, మేజర్గా ఆర్డర్స్ అంటే స్మెల్స్ రావడానికి స్మెల్ రిలేటెడ్ కెమికల్స్ కావచ్చు, లేకుంటే ఏజెంట్స్ కావచ్చు, డైస్ కావచ్చు, ఫ్రాగ్రెన్స్ ఏజెంట్స్ కావచ్చు. ఎగ్జాంపుల్కి స్మెల్ వచ్చేది ఏంటంటే డియోడ్రెంట్స్ కానీ క్యాంఫర్ కానీ ఇట్లాంటి వాటిలలో మేజర్గా మనము ఆల్డిహైడ్ అనేటువంటిది యూజ్ చేస్తున్నామని చెప్పొచ్చు. ఓకే, సో about up to this one will be, we can clearly say that the completion of aldehydes and ketones along with physical chemical properties and the preparation of aldehydes also finished. Now what we are going to discuss about carboxylic acids clearly. Okay, carboxylic acids, if we will see, we know that carboxylic acid has the functional group of COOH. The carboxyl group consists of a carbonyl group attached to a hydroxyl group, that is RC double bond O attached to a OH group. So generally it is known as what? RCOOH or aromatic compound. It is depending upon the group or alkyl attached to carbonyl carbon will be. Generally, if we will see, large number of carboxylic acids are found in nature. Some higher number of aliphatic carboxylic acids, known as fatty acids, that is stearic acid, palmitic acid, that we have seen in your X class syllabus, that is what soap preparation process. Occurs in naturally facts as esters or glycerol. Carboxylic acids serve as starting material for several other important organic compounds such as anhydrous and esters. And in preparation of these are all the compounds, carboxylic acids are the major components in the picture. We'll see the UPAC system of carboxylic acids once you observe the table children. First one structure is what it is, HCOOH it is there. Without only one carbon it is present. If aldehyde is there, generally we are calling it as what? Formaldehyde we are calling. But after that, one carbon, two carbons are there in that. Instead of hydrogen, one methyl group, it is written with acetic acid. propionic acid, butyric acid, isobutyric acid, oxalic acid. Like that, we are giving general names or common names. But whereas IUPAC names, if you are going to observe here clearly, HCOOH is there, it can be called as what methanoic acid. Why we are calling methanoic acid? The root word is we can see here meth. Why? Because number of carbons are only one will be. After that, the functional group it can be called with IUPAC name of oic acid. So meth plus oic acid it can be called as methanoic acid. If two carbons are present, that can be called as what ethanoic acid. If three carbons are there, that it can be called as propanoic acid. Like that, based on the number of carbons by giving the root word, we are calling with the IUPAC names clearly. Okay, those are all aliphatic acids. Now we have seen aromatic acids. Upon the benzene ring, one carboxylic group it is present. It can be called as benzoic acid. Similarly, phenyl acetic acid. Why? Because acetic acid formula is CH3COOH. In place of one of the hydrogen from the CH3, instead of that hydrogen, phenyl group is substituted. So because of that reason, it can be called as what phenyl acetic acid. And after that, dicarboxylic acid. That we have seen aliphatic acid is dicarboxylic acid is oxalic acid. Whereas aromatic dicarboxylic acid is what? Aromatic dicarboxylic acid is can be called as phthalic acid. I've seen here, and these are general names. But what are the IUPAC names we are going to pronounce? Those are all benzene carboxylic acid. Benzene ring is there. Upon the benzene ring, carboxylic acid it will be present. That is oic acid. Benzene carboxylic acid. Benzene carboxylic acid it is there. After that, phenyl group upon acetic acid is there. At second position, 2-phenyl ethanoic acid will be there. At second carbon, we are having a phenyl group. Because of that reason, 2-phenyl will be there. And ethanoic acid is what ethanoic acid generally we can call it. Benzene after, the benzene ring contains 2 carboxylic acids. That is what. But first position, we are having one of the oic acid. And at second position, we are having another oic acid. Because of that reason, it can be called as benzene 1,2 dicarboxylic acids we are calling. Structural of carbonyl group, how we are going to explain. We'll see C double bond OH is there. In carboxylic acids, generally, if you observe clearly, they are separated. Carboxyl carbon is separated by about around 120 degrees, and the carbon is less electrophile than the carbonyl carbon. అంటే ఆల్డిహైడ్లో ఉండేటటువంటి కార్బన్తో కనుక కంపేర్ చేస్తే కార్బాక్సిలిక్ యాసిడ్లో ఉండేటటువంటి కార్బన్ యొక్క ఎలక్ట్రోఫిలిక్ నేచర్ అనేటటువంటిది సమ్వాట్ ఇట్ విల్ బి లెస్ అని చెప్పొచ్చు. ద పాసిబుల్ రెజనెంట్ స్ట్రక్చర్స్ కూడా మనకి కింద ఇచ్చాడు ఇక్కడ. డబల్ బాండ్లో ఉన్న ఆక్సిజన్ పైన ఎలక్ట్రాన్, డబల్ బాండ్ ఎలక్ట్రాన్స్ ఆర్ మైగ్రేటెడ్ టువర్డ్స్ ఆక్సిజన్. Then the unpaired electrons which are present as lone pair on the oxygen, those can be are going to stabilize the carbocation which it is formed on the carbon. That is carbon positive charge is being stabilized by the electrons which are present on the oxygen. Then again oxygen is going to get one of the oxygen because of the deficiency is getting a positive charge, and one of the oxygen because of the efficiency it is going to get a negative charge will be. So this is the resonance structures and nomenclature of the carboxylic acids. After that, how we can prepare aldehydes and carboxylic acids. How we can prepare the carboxylic acids clearly, we'll see here. Methods of preparation of carboxylic acids. See children, already we have discussed this one in early in the lesson of alcohols. When alcohols undergone oxidation with chromium trioxide or potassium permanganate or potassium dichromate, acidic alkaline media by potassium dichromate and chromium trioxide in acidic media. So chromium trioxide and H2SO4 will be there, which can be called as what? Jones reagent. Primary alcohols are readily oxidizes, immediately oxidizes with common oxidizing agents. So potassium permanganate, neutral, acidic alkaline medium also. Potassium dichromate and chromium trioxide with H2SO4 is called as, that means acidic medium లో ఉన్నటువంటి chromium trioxide ఏమంటున్నాం మనం అక్కడ జోన్స్ రియేజెంట్ అని చెప్పేసి చెప్తున్నాం. అసిడిక్ మీడియం లో జోన్స్ రియేజెంట్ చెప్తున్నాం. సో ఆల్కహాల్స్ ఏం లేదు, జస్ట్ వీఆర్ గోయింగ్ టు యాడ్ వాటర్, వన్ మోర్ ఆక్సిజన్ అండ్ రిమూవల్ ఆఫ్ హైడ్రోజన్. క్లియర్లీ వీ కెన్ అబ్జర్వ్ హియర్. చూడండి, RCH2OH ఉంది కదా ఇక్కడ. ఇక్కడ మనకు ఆర్ యాజ్ యూజువల్ ఆర్ ఉంది, కార్బన్ కార్బన్ లాగే ఉంది. 2 hydrogens are removed here completely. Those 2 hydrogens are removed. Instead of 2 hydrogens, 1 oxygen is given. Addition of oxygen or removal of hydrogen can be called as what oxidation only. These are the alcohols undergone oxidation will form acids. Similarly, decanol is going to form the decanoic acid. So alcohols in generally involved in the oxidation process and going to form what carboxylic acids clearly. Okay. After that, from alkyl benzenes. So how can we prepare from alkyl benzenes? Aromatic carboxylic acids can be prepared by vigorous oxidation of alkyl benzenes. Any alkyl benzene if we have taken, that's what methyl substituted benzene is there. That methyl substituted benzene, whatever it will be present here, the methyl substituted benzene in presence of potassium permanganate, alkali potassium permanganate, it will be present of that. After that, what will happen? When it is undergone the reaction with the methyl benzene, it is forming the methyl group is completely hydrolyzed as oxidized as what CO, okay, potassium salt of benzene ring it is formed. When it is undergone hydrolysis again, the potassium salt of carboxylic group is directly changed as what a carboxylic acid. In that manner, we are going to prepare from the toluene is benzoic acid. Similarly, if we have taken propyl benzene, the same reaction is going to be occurred. Because of that reason, from the potassium permanganate, basic potassium permanganate here will be treated with the potassium permanganate. At that time, potassium permanganate when it is treated with it, KOH will be there. At that time, what it is going to be happen? So COOK will be there. That is potassium salt of carboxylic acid is there. Again, it is undergone hydrolysis. It is forming benzoic acid will be. From nitriles and amines will be. Nitriles are hydrolyzed to amides. That time when we have taken nitriles, already nitriles here we have taken in previous lesson also we have observed. Nitriles undergoes hydrolysis, it can be formed as what? C double bond O NH2. Amides are going to be formed. In the previous lesson we have seen amines will be. When cyanides undergo hydrolysis will are forming their amides. Amines undergoes heating with the H plus or OH minus. At that time they are going to get as amide group is changed as carboxylic group. That means what? Nitriles are hydrolyzed to amides and then acids by the hydrolysis process only in the presence of H plus or OH minus as catalyst. Mild reaction conditions are used to solve the reactions or amide stage will be. Then amide what we have taken in the second reaction, that is what ethanamide, because we are having two carbons are there, CH3CONH2 is there, ethanamide is there. Ethanamide undergoes hydrolysis, it is forming what ethanoic acid plus ammonia is formed here. Similarly, benzamide here we have taken. Benzamide here we have taken. When benzamide is treated with the undergone hydrolysis, benzamide undergoes hydrolysis, it is forming as what? Benzoic acid. So whatever the still now what we have discussed once we will see initially aldehydes undergoes oxidation will form acids will be. Similarly, from alkyl benzenes undergoes oxidation, but after the hydrolysis we are going to get the carboxylic acids. After that, nitriles undergoes hydrolysis. On the continued hydrolysis first they are going to form amides. After that they are going to form what? Acids will be. Then now in the fourth reaction with the preparation of fourth preparation, if we observe here, alkyl magnesium halide we have taken in presence of dry ether. When they are treated with carbon dioxide, that is dry ice, they are going to get water salts of carboxylic acids. To form a magnesium salts of carboxylic acids are formed when they are undergone hydrolysis. Again, what? They are going to form carboxylic acid. Everywhere we are going to observe here what? The potassium salt of carboxylic acid as well as amides as well as what? Magnesium salt of carboxylic acids. What we are going to get? It means what? Any salt of carboxylic acid if we have taken at that time, clearly we are going to get what? Acids only. Here COOH, everywhere we are going to get carboxylic acid after completion of the hydrolysis process only. So the last step here we are going to get as what? A hydrolysis process. That is what from amides and alkyl magnesium halides will be. From methyl halides and anhydrates. So acyl halide, this is what acyl chloride here we have taken. That is acyl chloride when undergone uh, hydrolysis. At that time, acyl chloride is also hydrolyzed as acid as well as Cl minus will be. It means acid chloride is readily hydrolyzed to form with aqueous base to give carboxylate ions, which is acidification and provides corresponding the carboxylic acids will be. So similarly, what RCOO minus acylate ion is formed, carboxylate ion is formed. Then again, what we are it is treated with the H3O plus. Then RCOO minus can be formed as RCOOH. After that, benzoic anhydride we have taken from the acyl halide, it will be completed. After that, benzoic anhydride we have taken. After completion of the after taking of benzoic hydride also, it is undergone hydrolysis. Again, 2 moles of benzoic acid. Why? Because the acetic anhydride in the benzoic anhydride structure, the oxygen is bonded with 2C6H5CO groups. Because of that reason, what is going to be happen clearly, if you observe, the bond is broken at the O and carbon. So because of that reason, the bond is broken, and after that, hydrogen is treated with this carboxylic group. So because of that reason, acid is going to be formed. Clearly we can observe here 2 moles of benzoic acid is forming. Then benzoic ethanoic anhydride we have taken. That means what exactly? Clearly we have taken in the second reaction 1 mole of benzoic anhydride, which contains the similar group. So we are getting 2 moles of similar acid, that is benzoic acid. We are going to get, if we have taken the acetic anhydride, the anhydride group is bonded with 2 different alkyl groups. At the time, acids whatever we are going to get after complete the reaction, those also we are going to different carboxylic acids only. Why? Because anhydride group contains one benzyl group, one phenyl group, as well as one methyl group. So with one methyl group, one acid is going to be formed. With one phenyl group also, one acid is going to be formed. From esters, if we will see acidic hydrolysis, if we will do the esters, then we are going to get, it is a reversible process. Already we know that when alcohols reacted with alcohols are reacted with acids in presence of a concentrated of acid at the temperature of 170 degrees centigrade, generally we aware of that acid plus alcohol in presence of a concentrated acid, they are going to give esters by giving a byproduct of water, that we know very well. Similarly, if the reaction is completely ఒకవేళ కనుక రియాక్షన్ కనుక మనము, if the reaction is completely reversible, that means the same reaction is coming, that means doing once again in the backward manner. At that time, what the ester whatever it will be formed, that is going to give on acidification, give carboxylic acid as well as alcohol also. These both are going to be formed. It is a reversible process. See here what it will be, one ethyl and one benzoate group it is there. And here if we see the alkyl group, it is going to be formed in alcohol, and the benzoate group whatever it will be present, that it can be formed as what benzoic acid will be. Next we have taken ethyl butanate. One is ethyl carbon and one is a butanate ring will butanate group will be. So one of the sodium salt of ethanoate it is forming, as well as alcohol it is forming. Sodium salt of butanoic acid. Sodium salt of butanoic acid it is formed, and ethyl alcohol it is formed. When it is undergone hydrolysis, at the time it is also forming butanoic acid clearly. Okay. After that, if we will see, these are the preparation of these are the preparation of what carboxylic acids generally. After that, physical properties. Physical properties generally, if we will see, these are clearly you can observe here. Aliphatic carboxylic acids up to 9 carbon atoms, the colorless liquids at room temperature with unpleasant odors. And after that, ketones. If we will see the boiling points of the carboxylic acids, clearly you'll observe what they are saying is the higher acids are wax-like solids, practically odorless due to than liquids than aldehydes, ketones, and even alcohols of the comparable molecular mass also. This is due to more extensive association of carboxylic acid molecules with intermolecular hydrogen bonding. So carboxylic acid contain which type of hydrogen bonding will be? Intermolecular hydrogen bonding. To the hydrogen bonds not broken completely. Hydrogen bonds are not broken completely, even the vapor phase also. Because of that reason, carboxylic acid exists a dimer phase in the vapor phase or an aprotic solvents. అవి maximum vapor phase లో మనకు vapor phase లో కూడా these are the carboxylic acids are going to be exist as dimer. ఎందుకంటే అంత ఈజీగా బ్రేకేజ్ అనేటటువంటిది ఉండకపోవడం వల్ల. Simple aliphatic carboxylic acids having up to 4 carbon atoms are miscible in water due to the formation of hydrogen bonding with water. The solubility is decreasing with increasing number of carbon. చూడండి కార్బాక్సిలిక్ యాసిడ్ లో నెంబర్ ఆఫ్ కార్బన్ ఐటమ్స్ అనేటువంటి పెరుగుతున్నా కూడా ఆ మెజిబిలిటీ అనేటటువంటిది అంటే సాల్యుబిలిటీ అనేటటువంటిది ఏమవుతుంది తగ్గుతూ ఉంది. దట్ ఇస్ మీన్స్ solubility nature is going to be decreases by increasing of number of carbon atoms, because higher carboxylic acids are insoluble in water due to increase in hydrophobic interaction. మనకు హైడ్రోఫిలిక్ నేచర్ గురించి we know very well of hydrocarbon part. Because of that reason, up to four number of carbons which can have, it can forming as what intermolecular hydrogen bonding. Because of that reason, those can going to dissolve in the water or miscible in water very easily. If the number of carbons are going to be increases, at that time the miscibility of the acids somewhat it is difficult. They are clearly saying is that. Okay, now chemical reactions we'll see clearly. What are the chemical reactions? Carboxylic acids chemical reactions once we see. The reactions of carboxylic acids are classified as follows. So everywhere carboxylic acid we have taken treatment with sodium metal as well as sodium hydroxide as a base, as well as sodium bicarbonate is a mild base. So everywhere and in every compound whatever we are taking as a second reactant, everywhere in the element, one of the element which is present as what sodium only. That sodium is treated with carboxylic acid. At that time sodium salt of carboxylic acid, everywhere we are going to get sodium salt of carboxylic acid. But the major difference here we are going to get in the first compound, along with the sodium salt of carboxylic acid, hydrogen gas it is formed. Similarly, H2O in the second case, why? Because it is a base and acid reaction, and we can say it as well as neutralization reaction also. Why? Because acid plus base gives rise to salt plus water. It is also one of the neutralization reaction. Then it is also neutralization reaction. Sodium salt of carboxylic acid, water plus additionally here, which gas is liberated here? Carbon dioxide gas is liberating here. After that, carboxylic acids are dissociate in water to give resonance stabilized carboxylate ions and హైడ్రోనియం అయన్. మనం కార్బాక్సిలిక్ యాసిడ్ కనుక తీసుకొని వాటర్లో కనుక డిజాల్వ్ చేస్తే అది రెండింటిని ఫామ్ చేస్తుందంట. వీటిని ఒకటేమో హైడ్రోనియం అయన్ అండ్ ఇంకొకటి వచ్చేసి carboxylate ion which have the resonance structure like this. Clearly we can say that. Okay, next. So acidic nature, if we will say, of the carboxylic acids group, how can we explain the acidic nature of the carboxyl group will be? Where if we have seen, the strength of an acid is generally indicated by the value of pKa will be. Where if we have taken carboxylic acids are there, in the carboxylic acids, if the carboxylic acid are attached with the electron withdrawing groups and electron releasing groups, in which the acid, which acid is having more acidic strength. For example, if we have taken clearly, once you observe examples in clearly, we will see here CF3COOH is there, CCl3COOH, everywhere like this it will be. We have taken the CF3, it is there. Clearly you can observe here in the order of increasing order of their acidity based on pKa values. That means what? Which is having high acidic nature. Okay, that means what? And strength is going to be increases, acidic strength is going to be increases because of presence of electron withdrawing group. Where the electron withdrawing group it is present, at that time the electron withdrawing group will take the density of the electrons towards that. Because of that reason, carbon will get a which charge itself? Positive charge. Clearly, electron releasing group it or donating group it is there, it is uh, destabilizes the carboxylate anion. By means what? Carbon is getting more negative charge on the carbon, but whereas an electron withdrawing group it is also ready to take the electrons. Because of that reason, carbon is going to get what? Getting a positive charge immediately. That means by taking the electrons from the hydrogen, it can loses the H plus very easily. Because of that reason, it is more stable, that is gives more acidic strength it can have. So finally we can say that the carboxylic acids which have electron withdrawing group and as well as which have electron donating group, comparatively if we have seen, the electron releasing group and electron withdrawing groups both are present on the carboxylic groups which is having more acidic strength. However, obviously, we can surely say that electron withdrawing groups where upon which compound it will be present, that is having more acidic strength. Why? Because ఎప్పుడైతే ఎలక్ట్రాన్ విత్డ్రాయింగ్ గ్రూప్ ఉంటుందో ఎలక్ట్రాన్ డెన్సిటీని తన వైపుకు తీసుకోవడం వల్ల కార్బన్ మీద పాజిటివ్ ఛార్జ్ వస్తుంది. కార్బన్ మీద పాజిటివ్ ఛార్జ్ రావడం వల్ల సిఓ లో ఉండేటటువంటి ఆ హైడ్రోజన్ బాండెడ్ ఎలక్ట్రాన్స్ మీకు ఇవ్వడం వల్ల హెచ్ అనేటటువంటిది ఈజీగా లూజ్ అవుతుంది. అప్పుడు అసిడిక్ నేచర్ వస్తుంది. మరి ఇది తీసుకోవడం వల్ల ఎలక్ట్రాన్ ప్లస్ చార్జ్, కార్బన్ మీద ప్లస్ చార్జ్ వస్తే ఎలక్ట్రాన్ తీసుకుంటే మళ్ళీ హైడ్రోజన్ కూడా లాస్ అయిపోయి H+ ని లాస్ అవ్వడం వల్ల అసిడిక్ నేచర్ని షో చేస్తుంది. మరి ఎలక్ట్రాన్ డొనేటింగ్ గ్రూప్ కనుక మనం తీసుకుంటే what it is going to be happen, electrons are given completely, carbon is going to get which charge, negative charge. At time it's not easily possible to relieve the electron that much easily. H+ ని లాస్ అవ్వడం అనేటటువంటిది అంత ఈజీ కాదు. బికాస్ ఆఫ్ దట్ రీజన్ వాట్ ఎలక్ట్రాన్ విత్డ్రాయింగ్ గ్రూప్ ఉన్నప్పుడే స్ట్రెంగ్త్ ఆఫ్ యాసిడ్ విల్ బి మోర్. ఎప్పుడైతే ఎలక్ట్రాన్ డొనేటింగ్ గ్రూప్ ఉంటుందో అసిడిక్ స్ట్రెంగ్త్ అనేటటువంటిది ఏమవుతుంది, తగ్గిపోతూ ఉంటుంది అని చెప్తాం. సో దిస్ ఈజ్ అబౌట్ వాట్ acidic strength of the carboxylic acids. Okay, అంటే electron clearly the air with an along with the arrow mark he has given clearly once. Direct attachment of groups such as phenyl, vinyl to the carboxylic acid increases the acidity corresponding to the carboxylic acid. To the decrease expected to the resonance effect test shown below. Resonance also one of the point in order to explain the acidic nature of the carboxylic acid. Okay, we will see the presence of electron withdrawing group on the phenyl of aromatic carboxylic acid increases acidity, where the electron donating groups decreases their acidity. అంటే ఏం లేదు, సింపుల్గా చిల్డ్రన్ ఎలక్ట్రాన్ విత్డ్రాయింగ్ గ్రూప్స్ కంటే కనుక దానికి అసిడిక్ స్ట్రెంత్ ఎక్కువ ఉన్నట్టు, డొనేటింగ్ గ్రూప్స్ కనుక ఉంటే కనుక దానికి అక్కడ ఉన్నటువంటి కార్బాక్సిలిక్ యాసిడ్స్కి అసిడిక్ నేచర్ కానీ అసిడిక్ స్ట్రెంత్ కానీ తక్కువ ఉన్నట్టు అని చెప్పొచ్చు. ఆఫ్టర్ దట్ formation of anhydride, the chemical properties, some of the chemical properties of carboxylic acids in chapter. We'll see the some of the chemical properties of the carboxylic acids. It will be we have taken what one of the compound carboxylic acids on heating with the mineral acids like H2SO4, HNO3 with otherwise we can take it as phosphorus pentoxide also give corresponding anhydride. I means what? When carboxylic acid is treated with mineral acids, by losing the water molecule, it is going to form its anhydride will be. It is going to form its anhydride. And after that esterification, we know very well regarding the esterification process. We'll see 4-methoxybenzoic acid, the benzoic acid, nitrobenzoic acid, it will be there. Here, these three examples why he has given in order to explain the acidic nature or acidic strength of the compounds. Where the electron withdrawing group it is present as a nitro group, this is ready to take the electrons to stabilize the carbocation. But whereas OCH3 group it is there, it is destabilizes the carbocation, that is methoxy group. It is an electron releasing group. See,
Sir,
pKa.
conclude the session, sir. Time up.
Okay, sir. So based on the pKa values, we can finally say the acidic strength of the compounds. That is what for which one pKa value is less, that is having more acidic strength. In nitrobenzene, pKa value will be less. So in this manner, we can explain the acidic strength of the carboxylic acids. So for the next coming classes, by 1 or 2 classes, we'll complete the lesson. The chemical properties of the carboxylic acids as well as the uses of the carboxylic acids, we will complete. Okay. Thank you, children.